Hello everyone, this is Dr. Sandhya Tapadia from COAP. Today we are going to talk about binomial distributions using R. So first of all, we will quickly recollect what is a binomial distribution. Uh, that means the statistical part of binomial distribution, and then we will check functions in R which are used to get the various probabilities in the binomial distribution. Okay, so basically, before binomial distribution, we need to recollect what are the Bernoulli trials. Basically, it's an experiment which has only two outcomes, namely success and failure, where probability of getting success is denoted as P and that of failure is 1 minus P. So in binomial distribution, we consider experiment involving n independent Bernoulli trials, and then random variable x associated to that experiment is something whose value is number of successes in those n trials. So obviously x would be a discrete random variable because it will take values from 0 to n, 0 successes, 1 successes, and so on up to all n successes in the n trials. So the probability distribution function for that binomial random variable is given as f of x is n choose x into p raised to x into 1 minus p raised to n minus x. We all are aware of this. So the parameters in binomial distribution are n and p, where n is a positive integer and p is a real number which lies in the interval 0 to 1. Also, we know that mean of x is np and variance is npj, which is np into 1 minus p. So what we will do is now we will consider an example and we will check functions in R which probably we can use to get the desired probabilities which are asked in this example. We already know how to calculate these probabilities with the help of statistical tables and with the help of mathematical tools and formulae which we have. But yes, the software can make our life easy, and how, that we will check now. So let us check out this example. So example is, consider an experiment of rolling a fair die where success is determined by getting 4. Now we roll this die 8 times and then we find probability of getting 4s exactly 5 times, at the most 5 times, and moreover if probability of getting at the most x successes is around 0.95, then we need to find value of x. So we all are aware that here probability of getting exactly 5 successes is probability that capital X is equal to 5, isn't it? So how do we calculate that? Then probability of getting at the most 5 times successes means probability that capital X is strictly less than 5 or less equal to 5. At the most 5 means 5 is included. So probability that X is less equal to 5. That means it's a cumulative probability that which we will have to calculate. And in the last bit, they have said that probability that capital X taking value small x is 0.95. So capital X taking value at the most small x. Probability that capital X is less equal to small x is 0.95, and then we need to find value of x corresponding to that particular probability. So in R, we have 4 different functions which help us to calculate these probabilities. Okay, so there is this first function is d binom. It directly gives us the probability mass function that capital X, the random variable X, takes value small x. Okay, so d binom is used to calculate the exact probabilities. Then we have another function called p binom. It gives us cumulative probabilities, that is probability that capital X is less equal to small x. Q binom, it works like an inverse function. So if probability that capital X less equal to x is given to be p, we can find the associated value of x, small x over here. And R binom is an altogether different function. It is used to generate any number of realizations of x given in a specific binomial distribution. So as of now, we are not much interested in this R binom function, but yes, these D binom, P binom, and Q binom are of the most interesting functions for us. Okay, so let's go to R and try to solve that exercise over in R. Okay, so this is my R studio. So here I have already created that binom.r file in which I have written certain commands with the help of the functions d binom, p binom, q binom, and so on and so forth. Okay, so first of all, I mean, you can check it over here that I have written the exercise also in the comment of this source file, just to have that question in front of us. And let us check how to get that probability that capital X is equal to 5. So what is the syntax for this d binom function? So here, first of all, we write value of X, then uh, in the binomial distribution, we write bxnp, where x is the value of that random variable, n is total number of trials, and p is the probability. So here in R, that n is called as size. So whenever I need to mention the number of trials in that binomial experiment, I would be writing it as size, and then we need to write the probability. So probability P is written as PROB. And so the experiment was rolling a fair die, and uh, success was getting 4. So probability of getting 4 on a rolling die is 1 by 6. So probability is 1 by 6. The die was rolled 8 times, so size is 8, and the value taken by the random variable is exactly 5. So I'll be writing x equal to 5, and the function which we use to calculate this is d binom. So let me run this command and check the output. So you can see here the output. You can actually cross verify this with the help of our mathematical formulae and or with the help of statistical tables which we have. So answer would be 0.0042. It's around 0.0042. Then the second question was to find probability of getting force at the most 5 times. So that is a cumulative probability which we need to calculate. So we will go to that, but before this, I want to show you one more command where I can actually generate the entire probability distribution function. Okay, so here we calculated uh, the probability distribution when x takes value equal to 5, but we know that x takes value in the range of 0 to 8. So at those, so at each of these values, so at each of those x's, what would be the probabilities of getting those x's? So what we do is, here I have given the range x is from 0 to 8. So rest is everything is same, but I call this x taking value from 0 to 8, and I denote. So obviously I expect that this should generate a vector of size 9. Why size 9? Because I'm going from 0 to 8, so that 0 is also included. So it should generate a vector of size 9, and let me call that vector as prob distribution, that is probability distribution basically. And then let us see what uh, which vector we get and whether we have got the vector to be correct or not, so that we can check. So let me run this command. and let us see what vector we get. So here, if you check, we got 9 different values over here. 2 point, I mean, this e raised to minus 0, 1 means we need to multiply by 1 by uh, 10 or something like that. So, okay. So that's how we need to read these commands, and let us check whether this is right. So let me run, I mean, if I take summation of all these entries, this should turn out to be equal to 1. So that is what we mean by the probability distribution. Summation of all the probability probability distribution, summation f of x, x going from 0 to 8 should be 1. So let us check what this gives me. Sum of the vector means basically sum of all the entries in that vector. So let me run that. Yes, we got the sum is also equal to 1. So that is the thing which we get. Basically here, these values, if you check, they look quite clumsy, and probably it's difficult for us to guess those numbers. So what we can do is we can round off these values up to say 3 decimals or 2 decimals or 4 decimals as per our choice. So here I'm using the command round of this probability distribution, and this 3 denotes the number of decimals which I want. So if I run the command, see now the values of these probabilities are actually 0.233, 0.372, 0.260, and so on and so forth. So that is how one can get the probability distribution and probability of random variable at a particular value of x. Right? So that is done with the help of function dbinom. Now let us go to the second beat, that we want to find out the cumulative probability that capital X takes value at the most 5. So probability that capital X is less than or equal to 5. For that, we use the p binom function. It calculates the cumulative uh, probabilities. So here the first parameter which we give is q equal to 5. So q probably stands for accumulation or something like that in terms of R, because X we have already used in D binom. So here we use Q to show that we will be taking the cumulative frequencies ranging from 0 till 5. Okay. Size is again 8 and probability is 1 by 6. So let us check. If I put control enter, I get the value to be say 0.9995. And I can actually check this with the help of again d binom function, whether this is right or wrong. So this is anyways a cumulative frequency. If you remember, we had created this probability distribution table where we put value of x from 0 to 8. You know? So we can, and then we can take sum of the entries in that vector. So here we write this combination of d binom where x goes from 0 to 5, and so that probability distribution from 0 to 5 would be created, and then we take the summation. So this is a combination of 2 commands, and let us enter that. I'm expecting that I should get the same answer as the one which we got in p binom. So let us check what we get over here. See, you can observe in the console, the 2 answers are exactly same. So that's how that p binom function works. So obviously we know that if we calculate the probabilities for x taking value at the most 5, similarly, I mean, we can find out the probabilities that capital X takes values at least 5, at least 6 or something like that. And then what we do is we subtract the cumulative probabilities from 1. Okay. So in case, if in the example it were asked to find a probability of getting uh, at least 5 successes, then what we should have done was we had to subtract 1 minus probability that x takes value smaller than 5. So here my x goes from 0 to 4. So here actually 1 minus p binom function can also be used. So let me write that. I have done it with the help of d binom, summation and everything. So let us run this. And we got the answer to be 0.04, and I can actually get this with the help of p binom function as well. So let me write that. So that is 1 minus p binom, where q is equal to 4 now, because I want the success to be at least 5 times. So 1 minus success strictly less than 5. So q goes from 0 to 4. Size is 8. And probability is 1 by 6. And if I run this, I get again the same answer, as you can see over here. Now, if some probability is given, some cumulative probability has been given, how can we get the value of x associated to it? So for that, we use q binom function. As I said, the probability which was given in the last bit of example was around 95, and we need 0.95, and we need to find the value of x, small x, which we need to find. So for that we use q binom. Its syntax you need to note here. The given probability has been written. P is 0.95. Then size is mentioned and probability for that binomial distribution. So these are the parameters, basically size and probability. They are the parameters of the binomial distribution. They are mentioned as it is. And the first uh, attribute over here, uh, it is important. So here in q binom, it is the probability. In p binom function, that was the value for that cumulation. And for d binom, the value of x. Okay, so I think you get this now. So let us check what do we get over here. So let me run the command. So if you see this, the answer which we got is 3. Can we cross check whether we have got the correct answer? That probability uh, that capital X less equal small x is 0.95, and that is true for 3. So obviously here I'm not expecting exact answers, but we should be very close to the answers which we get. Okay, so let us cross check this with the help of p binom function. So what probability do we get? Do we get something around 0.95, 0.96, whatever? So let us run this command. See, the probability is 0.9693 something when q is equal to 3. Okay, so that's how that q binom function. Now let us quickly check what the R binom function does. So R binom basically used to generate any number of realizations of x given in a specific distribution. So here let us check first the command, and then I'll tell you what that n in that command represents. So R binom of n equal to 4, size and probability are parameters in the distribution. So if I run the command, you can see 3, 1, 1, 1. So here n basically is not the number of trials, but it denotes how many random values of that binomial random variable we need. So here we have given n is equal to 4. So what does it mean? That we repeat that binomial experiment of rolling the fair die 8 times, है ना? So that is our experiment. So we repeat that experiment 4 times, and in each of those experiment we expect to get different values of x. Okay, so as of now we probably don't need this R binom, but it plays an important role in the simulation and various advanced algorithms in statistics. Okay, so that is the use of R binom. And lastly, I'll just show you the bar plot for binomial distribution. So you already know how we can plot the bar plot. So bar plot for the probability distribution. So I have given the vector name probability distribution and names that x would be ranging from 0 to 8. Okay, so label on x-axis would be x, and on y-axis we would be representing the probabilities. So let us run the command and see. You can check the bar plot over here. So that was about the binomial distribution in R. I would suggest you to try out more and more problems with the help of R, so that you would be more comfortable with these commands. So with this, I would stop over here. This is Sandhya Tapadia signing off. Happy learning R. Bye bye.